Okay, these are the problems that we worked on Tuesday, October 6th, when I was unable to record the lecture. So I'm just going to record myself working them so that you guys have the notes and a record in case you need it. So we started with piecewise functions. So the Thursday before October 6th, whatever day that was, we looked at an intro to piecewise functions. In one of my classes I stopped here, and in one of my classes I actually did this one already. But we looked at how they are defined with different y's for different parts of their domain. So like in this example, when x is less than 2, y equals negative 3x. That's this pink line right here. And when x is greater than or equal to 2, so here's 2, it means everything to the right of 2, y equals x plus 3, which is this orange line right there. Okay, so we're going to graph another one down here. So this one has 3 parts to it. It's got the y equals 2x plus 8. If x is less than negative 4, y equals 1. If x is between negative 4 and 2, and y equals negative x if x is between 2 and 4. And then it's not even defined for x values greater than 4. There's just nothing. Okay, so we had not at this time learned about lines and slope and how to graph lines. But now that you've heard all that, I'm going to go ahead and use that information to graph these parts. So I'm going to graph y equals 2x plus 8. We'll do that one in pink. But only for x less than 4. Now, yes, it has a y-intercept of 8 and a slope of 2, but I actually don't really want to plot the y-intercept of 8 up here because I only want to graph it for x values that are less than negative 4. So there's negative 4. I only want to graph it out here to the left of negative 4. So I actually am just going to plug in a couple of values. I'm going to plug in, oops, I don't know why I put equals to there. I meant to put t-chart. I'm going to plug in negative 4 and negative 6. And actually, that's really all I need. That's good. Here we go. So if I plug in negative 4 right here, 2 times negative 4 is negative 8. Place that is 0. Technically, it's not defined by this graph at 0, but I would have an open circle there to indicate that it goes right up to 0, but it just doesn't get quite to it. And then when I plug in negative 6 times 2 is negative 12, plus 8 is negative 4. 1, 2, 3, 4. So it looks like it goes on negative 6, negative 4, so it goes down like that. Okay, so that's the part of the graph y equals 2x plus 8, but I've only graphed it for x values that are less than negative 4. So imagine kind of a vertical line right here where my cursor is. Right, x less than negative 4 means everything to the left of this over here. Right, next I'm going to graph y equals 1 for x values between negative 4 and 2. It's a constant, the flat function right there. There's y equals 1. It is defined at 1, negative 4 comma 1, so I'll put a closed circle there. And it's not quite defined right there. Oh, no, actually I'm going up to 2. 2. I'll put an open circle at 2. Let's just ignore that. Okay. This is going right up to 2, but I left an open circle because it's not defined at 2 because of the strict lesson thing. And then the last part is y equals negative x if x is between 2 and 4. So let's go ahead and plug in 2 and 4. That's 2, negative 2, negative x is negative 2, so there's 4, negative x is negative 4. Okay, I'm going to put a closed circle at 2 comma negative 2 because it's that equal to sign right there. And an open circle at 4 comma negative 4 right there. And there's the graph of that piecewise function. Okay, and then this one is slightly different just because of the description over here. So g of x equals 1/2 x squared if x does not equal 3. That means all other x values, or it's defined as y equals 0 when x is 3. Okay, so this is a parabola. We're going to go ahead and just plot some points on that. Although we will learn soon how to graph parabolas. I'm going to go with -3, -2, -1, 0, 1, 2, and 3 and 4. Technically, I'm not supposed to plug 3 into 1/2 x squared because it's not defined by that when x is 3. But I'm plugging it in to see where to put my hole in the graph. Okay, so -3 squared is 9, times a half is 4.5, 1/2 of 4 is 2, 3.5, 0, and then go back up. 4.5, that's where I've got my open circle. Right there. Or a hole is what I should probably call it. Okay. So 1, 2, 3, 2, 1, 2, 3, 4 and a half up there. 2, 2, 1.5. Now this should be a U kind of shape. It's curvy. Quadratics are curved. They're not V's. There's no sharp point at the bottom. Okay, so g of x is defined by this parabola. Everywhere right except for 3. When x is 3, y is defined by 0. It's just right there. Okay, so that's it for piecewise functions. Moving on then to lines. So lines are polynomials of degree 1. Of degree 1. There we go. Slope, that's the steepness. It's a measure of the steepness. In order to measure the steepness of the line, it compares the change in the y value to the change in the x values between 2 points. So the slope through these 2 points, x1, y1, and x2, y2, we usually call slope n. The difference between the two y values, so y2 minus y1, over x2 minus x1. So find the slope of the line passing through these two sets of points. Space here. Okay, so I'm sloping one through those 2 points. So here we go. We're going to compute n as, now it doesn't matter which point you call x1, y1 and which point you call x2, y2. You'll get the same answer. So y2, I'm going to call them in order, guys. I'm going to use this as y2, -2, minus y1 is 4, over x2 is -4, minus x1 is -3. It's -6 divided by -4 plus 3 is -1. So I get a slope of +6 on that one. And let's go ahead and graph that. -3, 1, 2, 3, 4 is there, and -4, -2 is there. So this is a really steep line. So it's a large number like 6, because 6 is large relative to the number 1. It's 6 times greater than 1, and 1 is the slope of a 45-degree line. So that's very steep. Also note that because it's got a positive slope, it's going up as you go from left to right. Okay, and in this one, the slope is y2 minus y1, it's going to be 5 minus -2, going right at 5 plus 2, over x, -1 minus 4, it's 7 over -5, -7/5. Right. So plotting these 2 points, 4, and then -2 is there, and -1, 1, 2, 3, 4, 5 is there. This is a little bit bigger than 1, so it's still on the steeper side, but it's negative, so the line is going down as we go from left to right. So there's essentially four different basic possibilities for the slope of the line. You could have a really steep positive slope like we did in the previous example. In that case, m would be greater than 1, both because it's positive because the line is going up as you go from left to right, and also because it's really steep. If it was a really flat slope, so it's still positive, it's still going up, but flat, then that would mean m is between 0 and 1. Or you could have a steep negative slope going down. That would mean m is less than -1, so it's a big number in absolute value. Or a flatter negative slope, m would be between -1 and 0. Okay, there's two forms for the equation of a line. There's point slope form and slope-intercept form. Those are the two useful forms anyways. This form is one that you'll use a lot more in calculus. So it is y minus y1 equals the slope m times x minus x1, where x1, y1 is any point on the line. And if we go look at the formula for slope, right here, y2 minus y1 over x2 minus x1, you can see it's not far to get from here to that equation, because if you multiply both sides of this equation by x2 minus x1, then you would have x2 minus x1 over here times m equals y2 minus y1, and then you just drop the subscripts that have 2's, because x2, y2, you let them be the variables xy, and you have this equation. That's how those are connected. Okay, and m is the slope, obviously. I didn't say that, but m is still the slope. So we're going to find, actually that is right there, the point slope form of the equation of a non-vertical line. Here we go. That's what I'm trying to do. Okay. So let's look at an example. We're going to write an equation in point slope form for the line with slope 6 that passes through the point 2, -5. Okay, so this is the x1, y1 point. So we have y minus -5 equals the slope 6, that's m, times x minus x1 is 2. You don't plug anything in for this x and y because those are the variables. Okay, simplifying, we have y plus 5 equals 6 times x minus 2. That's the point slope form for the equation of the line. Basically, you would just need to simplify the minus and negative. So, and then if we solve for y, we get y equals 6x, distributing the 6, minus 12. And then if I subtract the 5 from both sides, I'll have a minus 5 out there. Or y equals 6x minus 17 is another form, essentially slope-intercept form, for the equation of the line. So if we want to write an equation, there's another one, write an equation in point slope form for the line passing through these 2 points. First we're going to need the slope. So first thing we're going to do is compute the slope of the line between those 2 points. y2 minus y1 is -6 plus 1 over x2, -1, minus -2 is plus 2. We get -5 over -1 plus 2 is 1. We're getting -5. Okay, so if we want to use point slope form, notice right here, x1, y1 is any point on the line. So we have two choices. We could use this point or that point. Okay, so if we plug in the first point, we'd have y minus -1 equals the slope, -5, times x minus -2. And then if we use, if we use this point, we'd have y minus -6 equals the slope, -5, times x minus -1. Now those are both correct answers. They're both versions of the same line. To show that they're the same, we're going to solve them both for y. So I'm going to move the -1 over to the right and distribute the -5 at the same time. To get -5x minus 10 minus 11, or y equals -5x. Oh, so I should say -1. I was doing the math in my head. Minus 10 minus 1 is minus 11. On this one, when we distribute the -5, we get minus 5x minus 5, and then subtracting the 6 from both sides. As you can see, they are the same line when we solve for y. So these are the answers though, right? Here, these are the point slope form lines. Slope intercept, that's what this is. This is when you solve for y, that, and this right here. You have an equation of the form y equals mx plus b. The slope is always the coefficient of x, same thing here. And this constant out here is actually the y-intercept, because the y-intercept occurs when x is 0. If you plug in 0 for x right here, the mx term goes away and you get y equals b. So that's your y-intercept. I guess I could put that there. So let's graph this linear function that's in slope-intercept form. I'm going to start with the fact that the y-intercept is 1, so it's right here, and the slope we can just read off as the coefficient of x is 3/5. Now slope we can think of as change in y over change in x between any 2 points. Okay, so you can think of that as kind of your rise because y is your vertical change, so your run because x is your horizontal change. So we go up 1, 2, 3, over 1, 2, 3, 4, 5 to get to the next point. Or you could think of this as -3 over -5 and go down 3 because rise is negative, left 5 because run is negative to get to the next point. That's another way to interpret slope, because that's the rise and that's the run. Okay, let's write the equation of the line with slope -2/3 and y-intercept 2 in slope-intercept form. So slope-intercept form, that means mx plus b, and we're given the slope m and we're given the y-intercept b, so we just straight up write it -2/3 x plus 2. Or the equation of the line in slope-intercept form with slope 4 that goes through that point. Now this one's a little bit harder. We do know the slope, but we don't know the y-intercept. So we'd actually start in point slope form and plug in the point, and then solve that for y. Y equals 4x minus 7. So that brings us to horizontal and vertical lines. So we're going to look at the graph of y equals 3 and x equals -3. So for the y equals 3, there's not an x, but that basically implies that regardless of what x is, y is always 3, no matter what x is. So here's y equals 3. Here we go. 1, 2, 3. There's y equals 3, so for all these x's, y is always 3, and for all of those x's, y is always 3. So it's a horizontal line, and you have y equals your number. The slope is the change in y value divided by the change in x. Well, the change in y is 0 here because the y values don't change between those 2 points. So the slope is 0, and that's true for all horizontal lines. X equals -3 means, that's right there, that regardless of what y is, x is always -3. So all your x's are -3 for all the different lines. So that's the equation of this vertical line. Now here, change in y, we'll just go and compute it. Let's do change in y, like right there, for example, would be 2. But the change in x between these 2 points, the x values don't change. Change in x is 0. So the slope is 2 over 0 or undefined. And that's true of all vertical lines. They have an undefined slope. The general form of the equation of the line is the least useful, but you might need to know it or see it, so I'm going to use these. So ax plus by equals c equals 0 is the form where a, b, and c are constant. A, b, and c don't really mean anything, that's why it's not very useful. But sometimes you'll see it. So we're going to find the slope and y-intercept of the line, whose equation is this. So if you want to find the slope and the y-intercept, the easiest way to do that is just to put this in slope-intercept form and solve for y. So just moving the 3x to the left and the 12 to the right, we have 6y equals negative 3x plus 12. Then if we divide both sides by 6 to get y all by itself, those 6's cancel. Now over here I'm going to have to split this into 2 fractions to get it into slope-intercept form. The 3/6 is the same as a half. So we have negative x over 2 plus 2. And I would write this as negative a half times x plus 2 because that is slope-intercept form. So then you can read off that the slope is negative a half and the y-intercept is 2. Using intercepts to graph functions that are written in general form is pretty easy actually, because if you want to find the x-intercept, that occurs when y is 0. So if I plug in 0 for y, that term goes away, and I just have 3x minus 6 equals 0, 0. So 3x equals 6, so x is 2. There's my, x-intercept, that's right. And the y-intercept occurs where x is 0. If I plug in 0 for x, that term goes away. That's negative 2y minus 6 equals 0. So negative 2y equals 6, and y is negative 3. And then there's 2 points in the line, and you can just sketch in the line. You don't even have to compute slope or anything. So in summary, here's all the different forms for the equations of the line. Now let's look at parallel lines and perpendicular lines. The parallel lines have the same slope because they have the same steepness. So for example, if we want to find an equation of the line passing from negative to 5 that's parallel to the line whose equation is this, and then we're going to express the equation in point-slope form, slope-intercept form. Well, the slope of this line is 3, and we want to write an equation of the line that's parallel to this line. So the slope of our line is also 3, and it goes through this point. So I'm going to go with point-slope form. So 1 minus 5 equals the slope in times x minus negative 2. And we'll just stop there, actually. Perpendicular lines have slopes that are negative reciprocals. The reciprocal is where you flip a fraction upside down, and then they have the opposite sign. So, example, we want to find the slope of any line that is perpendicular to the line whose equation is this. So we need the slope of that line. So to find the slope of this line, I'm going to put it in slope-intercept form. I'm going to solve for y. So 3y is negative x plus 12. Now dividing both sides by 3, what we saw up here is that what happens is you basically end up dividing each term by that coefficient of y. So coming back down here, I'm going to divide this by 3 and write it as negative a third times x. And 12 divided by 3 is 4. So the slope of this line is negative 1/3. So the slope of our line is the negative reciprocal of this. So if we flip 1/3 upside down, we get 3 over 1, and then take the negative of this, so it's already negative, so it becomes positive 3 over 1. So that's the slope of any line that's perpendicular to that line. Now this is the same equation right here, x plus 3y minus 12 equals 0. So let's write the equation of the line passing through -2, -6 that's perpendicular to this line. So we already know that our slope is 3. It's the same line. And it goes through the point -2, 6. So it would be y minus -6 equals the slope 3 times x minus -2. And the last one here, write the equation of the line that goes through -5, 2, and is perpendicular to the line through those 2 points. So first you need the slope of the line through those 2 points. And it goes through 1, 2, and 4, 3. So let's find that slope using y2 minus y1 over x2 minus x1. So I get 1/3. So the negative reciprocal of that then is we flip it upside down, we get 3 over 1 again, but this time it's negative because this slope is positive. So the slope of our line is negative, and it goes through the point -5, 2. So y minus 2 equals -3 times x plus 1. Okay, and I would like to graph one of these. I think actually, let's graph this one because I've got these two solved. You can see that they're perpendicular. So this is the same as that equation. These are the same lines. So in graphing this, I'm going to use the slope-intercept form. Y-intercept is 4. Slope is -1/3, so down 1, right 3. Down 1, right 3. Or up 1, left 3. Okay, so that's the slope of the line that we're given. And that's the equation or graph of this line that we're given. And then let's graph this one to make sure that they look perpendicular. So this one, let's go ahead and solve. Well, no, let's just use the point -2, -6. Which is -2, then 1, 2, 3, 4, 5, 6 right here. I have the slope of 3, so that means up 3 over 1. Up 3 over 1. And you can see they do look pretty perpendicular. Right, which means that that is a right angle right there. 90-degree angle. So that's it for equations of lines.